This is 13-3, solving quadratic equations by completing the square. So in this chapter, what we learn to do, there are a bunch of different ways on how to solve quadratic equations. The first one we learned the other day. We called it the square root method. It's where we take the square root of both sides, get the quadratic alone, take the square root of both sides, and solve for x. But it doesn't work when you have a linear term. And what I mean by that is when you have like something like x squared plus 2x. We can't use the square root method. The linear term is that 2x. This is the quadratic term. Okay. The second method is the graphing method. And this is a good method, but it's not really that accurate. It's hard to use all the time because if your roots happen to fall, like let's say you are graphing and when we're solving for the x's, what we're really solving for in any of these, we're looking for where does it cross the x-axis? Well, what if that crosses in between -1 and -2? Then you have to eyeball it, so it's difficult to tell. It's really hard to tell if it's a third, a half, 5/16, so it's not a very accurate method, graphing. The last is the quadratic formula, and that's where we find our a, our b, and our c, and we just substitute it into a formula. This is generally the easiest way. We teach it last. A lot of kids tend to depend on the quadratic formula because it's just substitute and solve. But if I have big numbers, I generally don't go, that's not my go-to method. But it always works. With the square root method, we can't always use it. Factoring method, that's where we set both equal to 0 and use the zero product property. Now this really only works for a group of quadratics that are factorable. Not all trinomials are factorable. Not all quadratics are factorable. If it's factorable, it's the fastest. And what we're going to work on today is completing the square. This always works. All right. I'm going to first do this conceptually. Okay. So I'm going to use some algebra tiles and I'm going to draw them. Okay, so let's start with, what does this phrase look like? I'm going to actually pretend this says +7. Okay, so if I had something like this, with algebra tiles, this is the measure of an x. And if I have what this phrase would look like, and if I put a measure like this by a measure like this, they're both, this is a measure of x and this is a measure of x, it would give me a shape that looks something like that. So that would be an x squared. According to this trinomial, what I have are 6 x's, an x squared, and 7 ones. I guess 1, 2, 3, 4, 5, 6, and 7. So the value of these things are very different. They look different, they act different. We would never put them into the same pile because they're all different. We're sorting them. Okay? So if I were multiplying, now let's use an area grid. I should make it in black. Forget about this equation. I'm not using it. Let's say I'm multiplying x, that's my x, plus 1, 2, 3 times x plus 1, 2, 3. We're going to need a tile that looks like a measure of x and a measure of x. That would be like that. And this would be a measure of x times 1, which gives me an x. What did we say that big square was? It's an x squared. This one would be another x times 1, so that would be an x. And the third one would be an x. Now this one is another x by 1, gives me the area of x. Now, right in here, we're going to have, this is a measure of 1 by a measure of 1. Measure of 1 by a measure of 1. So what that creates is a perfect square. My drawing isn't perfect, but if I use the tiles, it creates a perfect square. When we talk about completing the square, what they do is they give us everything except this. Algebraically. They give it to us and they want us to complete the square. Figure out how many to complete that perfect square. Anytime I have, this is a, oh, oops, that's not what I'm going to do. Okay, so this is, let's look at what this equals. X, this is x plus 3 times x plus 3. Altogether, we end up with x squared right here, plus 1, 2, 3, 4, 5, 6 x's, plus 9. So every time we multiply two things that are exactly the same, we'll get a perfect square trinomial. And a perfect square trinomial will always create the perfect square with the tiles. So with completing the square, what they want to do is they're going to end up giving you x's and your x squared, and they want you to complete the square. Only we're going to do it algebraically without the tiles. Alright, so now let's try it. So with this equation, the first thing I have to do is get rid of that 7 so I can turn it into a perfect square trinomial. So the way I get rid of it is I do the inverse, add 7. Now I've got that space that's open. Now we just did this one. We know that when we saw an x squared plus 6 x's, how many little ones did I have? I had 9. That part right there, when I add the 9, that is completing the square. If I do that to one side of the equation, I have to add 9 to the other. So now I simplify. And now what we can do is we can factor that. X squared plus 6x plus 9 really is equal to x plus 3 squared. Now that my binomial quadratic is isolated, I can take the square root. So we take the square root, now we're going back to 13.1, square root property. Square root of both sides. Now, remember, when I take the square root of binomial, I have to take the absolute value. And the absolute value of 16 is 4. To lose the absolute value, I have to set it equal to plus or minus 4. And then I subtract 3 from both sides. And so my two answers are negative 3 plus 4. I split at the end. Okay, I know that back in chapter 9, we split here. But we're not going to do that. We're going to simplify it down and split at the end. I want you to get used to seeing how the quadratic formula is going to look. Okay? So our next one, and these simplify to 1 and negative 7. Alright, so that's completing the square. Now completing the square is setting this little place right here, setting this place, getting it empty, moving it over, and leaving it open so I can make this a perfect square trinomial. Alright, so now there is a way to actually, okay, so let's practice completing the square. So I know the square root of this term, oops, okay, I know the square root of the first term is going to be an x. Okay? The way we figure out that last term is we take the b term. Remember, in the equation ax squared plus bx plus c, the coefficient of the linear term, we take the 6, we divide it by 2, and we square it. So 6 divided by 2 is 3, and 3 squared is 9. And so that equals x squared plus 6x plus 9. Now if I were to factor it, it's going to be x plus 3 squared. So notice when I divide that by 2, whatever I get is what goes right here. So let's try it. Okay, let's factor first. Let's get the factor first. So I'm going to take the first term, divide it by 2, I get 6. So this one's going to be x plus 6 squared. And in my last box, I'm going to get 36. Okay, pause the recording and try 3 and 4. Go. Okay, now check your work. For number 3, I'm going to divide by 2. I get a negative 9. So what's this going to be? We know it's going to be y squared. And we know it's going to be a 9. To get that negative there, it's got to be a minus. Now, if I square the negative 9, we get 81. Next one, divide by 2. We get 7. So it's going to be k minus 7. You know what? Squared. And when I square that, I get 49. So the completing of the square is actually these boxes that we filled in. Alright, the last one gets a little bit trickier because it's got a leading coefficient. Now, I know this is going to be a perfect square trinomial. So, because it tells me, with a perfect square trinomial, oh, and I did make a mistake right here. Should have called it m. In a perfect square trinomial, I know that's the first square root. This is the last square root. So, and when I multiply those two together, I get k times negative 7 is negative 7k. If I double that, I'll get the middle. Y times negative 9 is negative 9y. Times 2 gives me negative 18y. M times 6 times 2 is 12m. X times 3 times 2 is 6x. 6x. So I'm going to do the first thing I know. The square root of 4t squared is 2t. Okay? Now remember, every time I multiplied it by 2. Well, I don't know what it is, but I know that I'm going to end up multiplying by 2. So 2t times 2 is 4t times what equals 20t. So I'm multiplying by that 2 first. Okay, and so again I went 2t times 2 is 4t times 5. Okay, and it would have to be a minus. Now I'm going to check myself. So I'd have 2t times 2t. End up with 4t squared. I get my 25. And here I get a 10t. And here I get a negative 10t. And that works. And it is a perfect square. So the number that goes in here is 25. Now I had another student that did it a different way. Pause the recording if you want to write this because I'm going to erase. I had another student that did it a different way. She did the same thing we did before. She took the 20t, she divided by 2, and she got 10. She got 10. She squared it, she got 100. The thing is, you have that leading coefficient. She then divided it out, and that's how she gets her 25. Because it's not 100, it's 25. She divided out the leading coefficient. So that's completing the square. Now we're going to use it. Now we're going to use it to solve. All right. Okay, so step 1 in completing the square. We have to make it empty so that we can set it equal to 0. So we can get that space and turn it into a perfect square trinomial. So subtract the 5. And now, to get that middle term, I take that b term. I take the b term. Remember, in ax squared plus bx plus c. I take the b, the one that's before the linear term, and I divide it by 2, and then I square it. Okay? So I'm taking my negative 8, dividing it by 2, and squaring it. Negative 4 squared would be 16. So now I'm going to add 16 to both sides of the equation. Okay, the biggest problem I get with completing the square is that people forget to add on the right side of the equation. Okay, so now I'm going to factor both sides. Well, I'm going to factor the left side, that's all I can factor. Next step, to get rid of the square root, I have the square, I have to take the square root of both sides. Square root property. I get to lose the square root, I get the absolute value of x minus 4 equals radical 11. Now, to lose the absolute value, I have to do plus or minus radical 11. And then I add 4 to both sides. Now, this is a perfectly good answer. What this means is 4 plus radical 11 and 4 minus. Now, if you're doing mathematics, this is the way we like your answer. We don't want you to estimate it. We can estimate it. 4 plus radical 11 is a little less than square root of 4, so it's like 3.5. 4 plus, so 7.5 or minus 1.5. But This is more accurate, so mathematicians like it this way. All right, pause and try the next one on your own. Now check your work. Subtract 6 on both sides. And remember, each time during this recording, I want you solving these by completing the square. So, when I have an odd number, I'm still doing the same thing, -5 divided by 2. And then square it. Keep it in fraction form. Nothing wrong with a fraction. Add 25/4. And I'm going to add 25/4 here. Now, the only way I can add 25/4 to -6, I'm going to have to make that -6 a common denominator. So I'm going to have to multiply -6 by 4/4. That gives me -24/4. When I simplify the right side, I get 1/4. And now I have to factor this left side. Now remember, it's not so difficult because it's a perfect square trinomial. The square root of x squared is x. We know it has to have a minus sign because there's a minus sign there. Square root of 25 is 5, and the square root of 4 is 2. There we go. Not so hard. Okay? Now, to get the square by itself, take the root of both sides. When I root a fraction, what you need to think about is always rationalizing the denominator. So, absolute value of x minus 2 is equal to radical 1 over radical 4. Radical 1 is 1, radical 4 is 2. So it's -5/2 equals plus or minus 1/2. Taking the square root on the right, losing the absolute value on the left. And now I add 5/2 to both sides. So I have 5/2 plus 1/2 and 5/2 minus 1/2. And these work out to pretty good numbers, 3 and 2. 6/2 and 4/2. So your two solutions are 3 and 2. Now somebody said to me, why can't I just solve by factoring? At the end of 13.4, you can choose any method you want. And you're right, by factoring it's a lot less work. I know what multiplies to, I could have solved by factoring. Multiplies by 6, adds to -5. It's -3, positive 2. So I know that's going to be x plus 2 times x minus 3 equals 0. And my solutions are going to be 2, -2, and positive 3. Oh no, sorry, whoops, it has to be minus 2. Minus 2. So with that, if that's a minus sign, the answer is going to be positive 2 and positive 3. So yeah, it's a lot less work, but this is a method you have to learn. You will not place on your high school exit exams if you do not learn how to complete the square. Any standardized test, any SAT, you will need to learn how to complete the square. So please, all problems tonight, you have to complete the square. When we're at the end of the chapter, you get to choose your method. But tonight, I want you learning this method. All right, so let's continue. Try it again. Now, our space is empty already. We don't have to subtract anything. So you just have to complete the square. Pause the recording and try it on your own. All right, check your work. To complete the square, we divide 7 by 2 and then square it. We get 49 over 4. I have to add that to both sides. I then factor left side and it becomes x squared 7 over 2, minus 7 over 2 squared. Next step, take the square root of both sides. We're very lucky here because the right side's a perfect square. End up with the absolute value of negative 7/2 equals 7 over 2. And to lose the absolute value, I have to set it equal to plus or minus. Then add that additional 7 over 2. So we get 14/2, and we get 0. 14/2 equals 7. The other one equals 0. And yes, we could have factored this one too. But again, remember, we're practicing. All right, solving by completing the square when you have a leading coefficient. This is not that much more difficult. I do it a little bit more differently than my PowerPoint, but you can do it either way. The first two steps are kind of, it doesn't matter what you do first. They clear the 4. But I do this. Let me go back. I get rid of my leading coefficient first. Divide all terms by 2. And so on the first term, I'll be left with x squared plus 7 over 2x minus 4 over 2 equals 0. X squared plus 7 over 2 minus 2 equals 0. And then I would start to complete the square. 7 over 2x. Add 2. X squared plus 7 over 2x equals 2. Middle term, 7 over 2 squared becomes plus and what we have is x plus 7. We're going to factor it. Sorry. Yeah, that's what it would have been. X plus 7 halves squared equals, now I'm going to have to do 8 over 4. So that becomes 57 over 4. Now, I'm going to go back to the PowerPoint and look at what they do different. One more time. What I did was I got rid of the leading coefficient first. What they do is they subtract that negative 4 first, then divide out by the leading coefficient. Okay, so let's try it. Plus 4, divide by your leading coefficient, all terms. Now, what I've got, doing the same thing that I was at, add 49 fourths to both sides. Oh, whoops, you know what? I made a big mistake. So when I have 7 halves, remember, I have to multiply by 2. That's 7 over 2. To divide by 2, I skipped that step, is the same thing as to do this. But when we divide fractions, we really have to do this. We multiply by the reciprocal. So that's why I get 7 over 4, and then we have to square that. Okay, so let me clear that. 7 halves divided by 2. I'm really 7 halves multiplied by 1 half. And then square that. We get 49 over 16. 49 over 16. And now what we've got, take the square root, factor the left, add the numerators. This is where I went wrong because I didn't divide 7 halves in half. I get 81 over 16. Take the square root. Square root of 81 is 9. The square root of 16 is 4. So we end up with 9/4. Absolute value plus or minus 9/4. Subtract 7/4. we branch it off. Negative 7/4 plus 9/4 is negative 2/4, and the other one would be negative 16/4. So that equals 1/2 and negative 4. All right, so now why don't you pause it? Let me go back. If you need to take any notes, why don't you pause it and you try the next one on your own. All right, now check your work. I'm subtracting 1, divide out the leading coefficient of 3, okay. Take the middle term, divide it by 2, which is really multiplying by 1/2, so I get negative 5/6 squared. So negative 5/6 would be 25/36. Add that to both sides. Make sure you're adding to the right side too. When I take the square root, I get x minus 5/6. Other side simplifies to 13/36. Take the square root. Every time we've been very lucky. Our denominator is a perfect square. We don't have to rationalize it in the end. Now we can write this 5 plus or minus radical 13 all over 6. It's the same denominator. And there's our answer. And that is completing the square.